एक बार फिर से आप सबों का स्वागत हमारे ऑनलाइन क्लास में। और मैं फिर से अपना परिचय दे दूं। अर्जुन कुमार, डिपार्टमेंट ऑफ केमिस्ट्री, डीएवी पब्लिक स्कूल, सीसीएल, गिरिडीह। कल के काम को आगे बढ़ाते हुए कल हमने ईएमएफ ऑफ सेल पर डिस्कस किया था। हमने आपसे आज जो है उसको आगे बढ़ाते हुए हमारा जो टॉपिक होगा एप्लीकेशंस ऑफ ईएमएफ, एप्लीकेशंस ऑफ ईएमएफ ऑफ ए galvanic cell, of a galvanic cell. Now we have two applications. Number one is related with feasibility of cell. So let us write here feasibility. Feasibility means possibility. Feasibility of a cell and cell reaction and cell reaction. Now, with the calculation of EMF value of a cell, we can predict whether the given cell is feasible or not feasible. For that, we write 2 points. One is if EMF of a cell is positive, the cell works. That means the cell is feasible or the cell reaction is feasible. But if EMF of a cell comes to be negative, the cell does not work. The cell does not work. That means cell is not possible. जो भी सेल लिखा हुआ है जिसमें ईएमएफ वैल्यू अगर उसका नेगेटिव आता है, इसका मतलब सेल जो लिखा हुआ है, जो दिया हुआ है, वो गलत है। दैट मीन्स सेल डज नॉट वर्क। सो दिस इज रिलेटेड विद द फिजिबिलिटी ऑफ ए सेल एंड सेल रिएक्शन। नाउ वी हैव एम्पल ऑफ एग्जाम्पल। फॉर एग्जाम्पल, सपोज वी हैव Cu2 plus C1, then salt bridge. This is Zn2 plus, and here is Zn. This one is concentration C2. Now, if we find out EMF of the cell with the values of electrode potential, if a standard electrode potential of Cu2 plus Cu is equal to 0.34 volt and E naught for Zn2 plus Zn is equal to minus 0.76 volt, then we can easily calculate EMF of the given cell as EMF or E cell or standard E cell is equal to E cathode minus E anode. E cathode minus E anode. Now we can put the value here. The cathode is this one, right side is cathode, left side is anode. we have already discussed yesterday. Now, E cathode, we put the value like this, minus 0.76, minus E anode, that is 0.34, and this comes to be minus 1.1 volt. So the value comes to be negative, minus 1.1 volt. So this negative value shows the cell is not feasible. The cell is not possible. Therefore, the above cell does not work. या फिर बोल सकते हैं कि ये सेल फिजिबल नहीं, क्योंकि ईएमएफ का वैल्यू या स्टैंडर्ड ईएमएफ का वैल्यू क्या आया, नेगेटिव आ गया। तो ये फर्स्ट एप्लीकेशन हो गया। उसी तरह से हमारे पास में कई एग्जाम्पल होते हैं। से फॉर एग्जाम्पल वी हैव अनदर एग्जाम्पल, इफ वी टेक Zn2 plus C1 salt bridge Ag plus Ag, here is C2. Now for this cell, this is another example. For this cell we are given E0 Zn2 plus Zn is equal to minus 0.76 volt and E0 Ag plus Ag is equal to 0.80 volt. This is given. Then if we like to find out a standard EMF, or we can write E0 cell. This is also called a standard cell potential. So EMF is also known as cell potential. So a standard cell potential is written as E cathode minus E anode. Once again, so E cathode minus E anode, and here on putting the value we can write E cathode is 0.80 minus E anode is minus 0.76. So this is equal to 0.80 plus 0.76, and this comes to be 1.56 volt, and 1.56 volt, that is in positive. That's why we can write the cell is feasible or the cell works. Therefore we can write the above cell is feasible. So there are various questions on feasibility of a galvanic cell. So very easily we can calculate a standard EMF for the given cell, and if it comes positive, the cell is feasible. If it comes to be negative, the cell is not feasible. Now we move on to the second application. Second application is dependence of EMF on concentration of electrode. Concentration of electrode. According to this application, with the change in concentration of electrolyte, EMF of the cell gets changed. So this is given by Nernst equation. This is given by Nernst equation. So here Nernst equation is used. This Nernst equation is used. It is used for the determination of EMF of a cell in which concentration of both electrolytes in anodic and cathodic compartment are given. So for that we have a general equation that is called Nernst equation. Even we can derive Nernst equation, but there is no necessary to derive Nernst equation because there are direct numerical problems based on Nernst equation, and that I will give you. So here is the Nernst equation. Nernst equation for a general cell reaction of the type AA plus BB, this gives CC plus DD. That means if a chemical reaction is represented by this general notation, AA means a small a mole of a small b mole of B, this gives a small c mole of C and a small d mole of D. Then Nernst equation can be written as E cell is equal to E naught cell minus 0.0591 by n log concentration of C to the power small c, concentration of D to the power small d, divided by concentration of A to the power small a and concentration of B to the power small d. So this also you have already gone through in chemical equilibrium in class 11. So similar to that equation, we can write Nernst equation or the given general cell like this or general cell reaction like this. So E cell is equal to a standard E naught cell minus 0.0591 by n. Here n is number of electron involved in the redox reaction. You know, the source of energy or the principle is a redox reaction, principle of galvanic cell. There is a simple question on what is principle of working of a galvanic cell. The answer is redox reaction is the principle of galvanic cell to work, and the source of energy is gives free energy. That I will discuss you in this chapter to some extent later on. So first you understand this Nernst equation and how this Nernst equation will be used for doing some numericals based on it. So N is number of electron involved, either loss or gain, okay, in a redox reaction, and here is concentration of product raised to the power equal to their numerical coefficient. Numerical coefficients are C and D. Similarly, this is concentration of reactants, and the powers are in the form of numerical coefficients. So say for example, if you have the reaction like this, Zn plus 2 Az plus, this gives Zn2 plus 2A. Say for example, by using zinc and silver, we make a galvanic cell. Galvanic cell, this can be written as Zn2 plus by taking the concentration at C1, and this is salt bridge. Here is Az plus, the concentration is C2, and this is Ag. Okay, so this cell reaction can be represented as galvanic cell. So here is anodic compartment. Why anodic compartment? We have already discussed many times, because this forms as anode, and at anode always oxidation takes place. This is salt bridge, and this forms as the part of cathode at which reduction takes place. So for this galvanic cell, we can write Nernst equation. So the Nernst equation is, so in a question this will be given to you, either this will be given to you, and you have to find out Nernst equation. So Nernst equation is what? E cell minus E naught, E cell is equal to E naught cell minus 0.0591 by N has value 2, because 2 electrons are involved in this process, and how it is 2, that also I will just discuss. Log now concentration of Zn2 plus into concentration of Az raised to the power 2 divided by concentration of what? Zn into concentration of Ag plus raised to the power. So in this way we can write Nernst equation for the given cell made by zinc and silver. So here we can write once more, E cell is equal to E naught cell minus 0.0591 by 2 log here concentration of Zn2 plus divided by concentration of Ag plus raised to the power 2. Here concentration of metal is equal to 1. Concentration of metal is taken as 1. So here also concentration of zinc and concentration of silver is taken as 1. So we can write E cell is equal to E naught cell minus 0.0591 by 2 log concentration of Zn2 plus divided by concentration of Ag plus raised to the power 2. So in this way, for any galvanic cell we can write Nernst equation. Now we have various numericals based on Nernst equation. So numericals based on Nernst equation. Find EMF and other variables. You can take it as home assignment, and if you are getting any sort of confusion, you can ask the problem whenever there is a doubt session. Okay, now we proceed ahead. Now the next part is concentration cell. This is very important galvanic cell, concentration cell. In concentration cell, we use only one type of electrode and electrolyte. One type of electrode and electrolyte. Say for example, we like to use zinc. Then we perform a cell like this. Zn2 plus C1, again here Zn2 plus, here C2, and here Z2. So whenever we have to prepare a concentration cell, so concentration cell consists of only one type of electrode and electrolyte. Only difference is that concentration of electrolyte is different. Here C1 is not equal to C2, or we can say C2 is greater than C1. In this way we can perform concentration cell. So whenever there is a question on define concentration cell, you can easily define concentration cell is a type of galvanic cell which is made up of same kind of metal and electrolyte, but they have different concentration of electrolyte. That means the electrolyte differs in its concentration. So this is concentration cell. So we can have here concentration of zinc cell, similarly concentration of silver cell, concentration of iron cell, magnesium cell. What are the metals? For any metal we can perform concentration cell. Okay. Now we have certain important relations or important formulae. But here, in case of concentration cell, very important thing that I was missing to tell you. Here, E naught cell is equal to 0. So whenever we consider a concentration cell, their E naught cell will be equal to 0. So this is the condition. Now, important formula is like this: delta Z is equal to minus NFE naught cell. First one. Second one is delta Z is equal to minus 2.303 RT log K. So here two important formulae in this chapter, and this situation is also associated with thermodynamics, chemical thermodynamics. So you might have studied in class 11 in thermodynamics delta Z naught or delta Z. Delta G naught is a standard gives free energy change. So delta Z naught is equal to a standard gives free energy change. Okay. Now N is number of electron. N is equal to number of electron involved in redox reaction that we have already discussed in next equation. F is Faraday constant. F is Faraday constant. You know, here 1 Faraday is equal to 96,500 coulomb. You might be knowing this is very important relation. And E naught cell, just we have discussed, E naught cell is a standard EMF of the cell. So in this way, we can find out delta Z naught if all values such as N, F and E naught cell are given. Okay. So with the value of delta Z naught, we can predict whether the given cell reaction is feasible or not feasible. So here is just I will tell you for feasibility of cell reaction with value of delta Z naught or standard gives free energy. So here very simply we can predict the feasibility if delta Z naught is negative. Delta Z naught is negative, the cell will be feasible. And conversely, if it comes to be positive, the cell is not feasible. So this to some extent we have already studied in class 11 in thermodynamics. So here also we can apply this one. So if the given cell is feasible or not feasible. This can also be tested with the help of delta G naught value that we can calculate by this formula. Now, in the second point, delta Z or delta G naught, anything you can write. If we give delta G naught, then temperature will be 25 degrees Celsius and atmospheric pressure will be 1 atm, that we have already discussed earlier. So here R is gas constant, T is temperature, and K is equilibrium constant. So here K is, we can write K is equilibrium constant. So by applying these two formulae, we can solve a lot of numericals based on it. So this is all about galvanic cell in detail. Thereafter, some important commercial cells. So let me write. Some important commercial cells. And these important commercial cells are, number one is dry cell, number two is mercury cell, number three is lead storage cell, number four is nickel cadmium cell, nickel cadmium cell, number five is fuel cell, and sixth one is corrosion cell, that is in the form of a rusting of iron. Rusting of. So all these cells, dry cell is quite common. Everybody knows dry cell. Mercury cell, this is used in hearing device these days. Lead storage cell in vehicles, or cars, buses, we use lead storage cell. Nickel cadmium cell, likewise, nickel cadmium cell is also a secondary cell. Fuel cell, very efficient, giving high efficiency. Neat and clean cell, fuel cell. And in fuel cell, the most important cell is hydrogen oxygen cell, that we will discuss. And finally, corrosion cell in the form of rusting of iron. And rusting of iron is quite common word, rusting of iron. Everybody, I think, is acquainted with rusting of iron. So whenever iron gets rusted in the presence of moist air, by developing a brown layer, brown coating on it, this happens through galvanic cell, and that is called corrosion cell. There also there will be an anodic reaction, cathodic reaction, and combining these two reactions, we will be having a cell reaction. So in all these cases, I will discuss one by one. First dry cell, then mercury cell, then remaining cells I will discuss with you one by one. So here, first dry cell. Now, dry cell is most common cell. You might have seen like this. Here is a casing. You know, this is brass cap. Here is brass cap, and in the middle, when a dry cell is turned out, if it is, broken, then you will be looking, there is a dark or black rod in between the dry cell and this black rod is graphite rod. This is graphite rod. Now this graphite rod is surrounded with some black powder, and this black powder is of manganese dioxide, and this casing again contains some white paste, and the white paste is of ammonium chloride, NH4Cl. Little zinc chloride is also mixed with this. So here Zn entire casing is made up of zinc. So here is, this one is zinc. So this zinc in the presence of NH4Cl or ZnCl2 acts as anode, while brass cap fitted with what? Graphite rod along with MnO2, manganese dioxide, acts as cathode. Excuse me, sir. So here dry cell, I will give you the detailed reaction for this dry cell in next moment. Now we discuss various reactions taking place in dry cell. So this dry cell is a type of galvanic cell, and if it is galvanic cell, then there will be anode reaction, cathode reaction, and cell reaction. So first, as anode, we have Zn in contact with NH4Cl, ZnCl2. This is as anode, and as cathode we can write, graphite rod, graphite in the form of carbon in contact with MnO2. This acts as cathode. So the two electrodes are Zn in contact with NH4Cl and ZnCl2 acts as anode, while graphite in contact with MnO2 acts as cathode. Now, how the cell reaction can be written? So first anode reaction, then cathode reaction, and combining these two reactions, we will be getting cell reaction. So let us write cell reaction. So first one is Zn gives Zn2 plus by loss of 2 electron, and here is oxidation at anode. So this is anode reaction, and when MnO2 with NH4 plus gains that electron, it is converted into Mn2O3 plus NH3 plus H2O, and we can balance it by putting 2 here. Here is 2, here is 2. So in this way we can get the balance equation. This is gain of electron, and gain of electron is the reduction, and reduction at cathode. Reduction at cathode. So whenever you are asked to write anode reaction, cathode reaction, so in this way you can write anode reaction as Zn2 plus by loss of 2 electron, and cathode reaction like this. And when these two reactions are added, we will be getting cell reaction. So here, by adding these two reactions, we get cell reaction. We get cell reaction as here is Zn plus 2 MnO2 plus 2 NH4 plus this gives Zn2 plus Mn2O3 plus 2NH3 plus H2. So this is balanced cell reaction. So in this way, for any commercial cell, we can write anode reaction, cathode reaction, and cell reaction. So for remaining 5 cells, you have to write anode reaction, cathode reaction, and cell reaction. This will be as homework. So the question is, write anode reaction, cathode reaction, and cell reaction for the following commercial cells. And the cells are, one I have already done for you, and for you now it is mercury cell, number 2 is lead storage cell, number 3 is nickel cadmium cell, number 4 is fuel cell, that is hydrogen oxygen cell, Number 5 is corrosion cell, that is in the form of rusting of iron. You can easily write all these cells by giving the figure that I have given for you in case of dry cell. Okay, and thereafter lot of numericals, NCERT numericals, other than NCERT numericals based on dust equation, you can do it. In next class I will tell you more about electrolyte.